Hello and welcome. It's your main man, Mr. Lyons here, and today we're talking about dilations, right? The first three transformations we talked about in the last couple weeks led to congruency. Same size, same shape, we just changed the location, right? Translation, reflection, rotation. But dilations lead to similar figures, right? And this is the definition of similar that we used to use, same shape, different size. But to be more specific, we're talking about it's the exact same shape but different sizes. What about their sizes have changed? Well, the sides are now proportional. The angle measurements stayed the same though, just like with these transformations. The biggest thing is that the sides of each figure are proportional. Let's remind ourselves what proportional means. It just means equal ratios. And we'll talk about what that means in just a second. But let's get a little specific with dilations, right? Like an eye, like that eye, when you look, you can do this if you go into the mirror, right? Close your eyes for a little while, and your pupil will become really small because it doesn't need a lot of light. But then when you open it up and you look in the mirror, your pupils will dilate and change size, right? Go ahead and try that out if you want to. Pause the video and go ahead and do that. A dilation is a transformation that either increases or decreases the distance between each point in a figure from a center of dilation. So here I have A to B is 5 centimeters, and then I have A to B prime, which it extended right to 10 centimeters. So our scale factor, our dilation, is times what? Times 2. Right? That's just a quick example. Let's keep going here. We use scale factors for dilations, right? And the scale factor here would be 2, right? 5 to 10, you go to 2, right? A scale factor is the constant by which a dilation changes size, okay? An image becomes enlarged if the scale factor is greater than 1. And the image becomes reduced if the scale factor is less than 1, right? The image stays the same if the scale factor is what? That's right, if it's equal to 1, right? 1 times anything is itself. We do not at all use negative numbers for scale factors. Right? Students usually think that when a shape is getting reduced, you use a negative number. No, reduce just means that the scale factor is less than 1. You can have numbers that are less than 1 that are not negative, right? Go ahead and write this out to the side. We use R to represent scale factor. You can have numbers there's infinite numbers right here. You can have numbers in between 0 and 1. They don't have to be negative, right? Okay? So let's give an example. This says, given line segment OP is 5 centimeters, and you don't need to use a ruler. We're just going to try to freehand it. Look at my dope art skills, yo son, right? O to P, 5 centimeters right here, right? O to P is 5 centimeters. Now, let's see if we can do a little bit of work here. Let's take a look at example 1, part A. If segment OP is dilated by a scale factor of R equals 4, this is our scale factor here, what is the length of segment OP prime? Well, if my scale factor is 4, looking back at your notes, if my scale factor is 4, I have to first determine, is my shape going to be enlarged or reduced? That's right, it's going to be enlarged. How do I know? Because 4, my scale factor, is greater than 1. So I know it's going to get bigger by how much? Well, it's a scale factor. What do you do with factors? You multiply them, right? So just to show what that looks like, I'm going to take line segment OP, multiply it by my scale factor, R, right? And that should give me what? OP prime. That's right. Do I know how long OP is? Can I substitute this for a value? Yes. This is 5. Do I know what my scale factor is? Yes. 4 equals OP prime. I don't know what this is yet, but I know 5 times 4 is equal to 20. So now I know what OP prime is. It's 20 centimeters. And that makes sense because it was greater than 1, so my line is going to get bigger here. I'm just going to put P prime over here. So this whole length right here is going to be 20 centimeters, right? It's not drawn to scale. We're doing that as best as we can, right? So now let's go down here to part B. If segment OP is dilated by a scale factor of 1/2, R equals 1/2 now, what will the length of OP prime be? Now let me ask you this question. Since my scale factor is 1/2, am I going to enlarge or reduce here? That's right, I'm going to reduce, meaning this should become smaller, right? It's become smaller because this is less than 1. So do the same thing over here. You take your line segment, going to multiply it by a scale factor to give me OP double prime. I hope I said that when I read this, right? I know that line segment OP is what? See if you can do this on your own. Pause the video, see if you can do it on your own. This is going to be 5, but my scale factor here is 1/2, which is equal to OP double prime. 5 times 1/2 is 5/2. Or you can say 2.5 centimeters, right? And that makes sense because it has to reduce because my scale factor is less than 1. So here, I'll put, I'm trying to get half right there. P double prime is 2.5 centimeters, right? We're dilating today, either enlarging or reducing today, okay? I'll go ahead and I'll check you on the next slide.